Power Standard 1 review for Module 1 Topic 2 sequences. Before we actually start with these couple problems, let's briefly review what sequences are. When we dealt with sequences a couple chapters ago, we dealt with primarily two types of sequences. The first one that we talked about was an arithmetic sequence. See if you can remember really quick what that is. I'll give you an example of an arithmetic sequence here. Let's say we start out with 1, and after that the second term is 5, and the third term is 9, fourth term is 13, and let's say this pattern continues forever. Alright, so our first term is 1, second term is 5. We can see that to get from 5 to 9, we're also going to be adding by the same amount. So in this case, we actually have a common difference of 4. Where our first term is 1, and to get each term after that, we're just going to add 4. Alright, these numbers that I'm putting below the sequence will just represent what term that is. So if I asked what the second term is, that's just the second number in the sequence, which is 5. So an arithmetic sequence dealt with adding, sometimes subtracting, depending on if we added a negative number. We can see the same thing, same type of pattern, just decreasing instead of increasing. So that would be an arithmetic sequence. We also talked about geometric sequences. Now what these are, something similar, but instead of dealing with adding and subtracting, it's more of multiplication / division. So in this example that I wrote over here, you can see that the first term is 1, the second term is 3, the third term is 9, and the fourth term is 27. Well, to get from each term to the next term, we are actually multiplying by 3. Now this 3 here is called our common ratio, where the 4 with the arithmetic sequence was called our common difference. Alright, so you will need to know both of these to work with these next couple problems. So make sure you have those two ideas down. Alright, so number 1. A bike rental company charges $12 to rent one of their bikes. Charges $12 to rent one of their bikes. The company charges an additional, that's a key word there, additional, that's going to be adding, 25 cents per minute for every minute the bike is rented. So let's see if we understand what's going on here before we even read the problem. We're renting a bike, and it costs $12 to rent the bike initially, and then for every minute that the bike is rented, we have 25 cents to pay. Alright, well let's see if I can actually make a nice table out of this. If you read letter A, it says describe the domain and range of the sequence and context in the first 5 minutes. So I know we want to be looking at the first 5 minutes. So I'm going to make a table on the side over here, and let's try to go to the first 5 minutes. So I care about minute 1, I care about minute 2, minute 3, 4, and 5. Alright, so 1 minute. This is where many students will make the mistake of, they see that the company charges $12 and they'll want to put a 12 right here because they'll say, oh, well, don't you start off with 12? Now, while you're correct, it does charge $12 initially, but think about after the first minute. So it's $12 to rent the bike, but for every minute it's 25 cents more. So after 1 minute, what is that going to be? Well, 12 plus 25 cents actually is $12.25. So my first term of this sequence actually is $12.25. Now continue the pattern, just keep adding 25 cents. Pretty easy numbers to add. We have $12.50 for a second term, $12.75 for a third, $13 for our fourth, and $13.25 for our fifth. Okay, so I have a nice table. If you look at just the right side, that's actually the sequence that represents this problem. So letter A says, describe the domain and range of the sequence in context in the first 5 minutes. Well, domain and range, this goes back to earlier in the semester we talked about. Domain are the x values or your input values. The range are all your y values or your output values. So in the table we made over here, you can think of these, the left side as your x values, your input values, or your term number. And you can think the y, or the right side of the column, the y as the range, or the outputs, or your term values. So when it says describe the domain, let's do that one first. We can say that the domain. So what do 1 through 5 represent in this case? If you think about the problem, it's either going to be money or minutes. Well, I can see that the right side has those dollar values, so this x side is actually minutes, and this y side are dollars. So the domain is the x values 1, 2, 3, 4, 5 that represent minutes. So this standard for 1.2 represents context. Do you understand what's happening behind the problem? All right, let's do the y values now. So these are your range values. So the range is the y values. And we can talk about what they are. 1225, 1250, 1275, and so on. We only care about the first 5 weeks, so we can actually stop after 325. All right, and again, what do these represent? The range is the y values from 1225 to 1325. That represents the amount paid for renting the bike. All right, so just recapping, domain, we're talking about the x values. For sequences, that's most likely going to be your term numbers. So 1, 2, 3, 4, 5, because they ask for the first 5 minutes. Now the range are the output values or the y values, which in this case is just talking about the money. All right, so part B, is this sequence arithmetic or geometric? Explain in the context of the problem. Well, remember what we said all the way at the top. Arithmetic is adding or subtracting. Geometric, think of as multiplying or dividing. Well, in this case, the problem straight up told you that the company charges an additional 25 cents per minute, right? So if you look at our y values on the table on the right side, we started with 12.25 and we added 25 cents to each term to get the next term value. So this sequence is arithmetic because the company charges an additional, that's the key word there, additional 25 cents each minute the bike is rented. Now, I do apologize for my handwriting. For those students that are watching this that aren't in my class, I hope you guys appreciate your teacher's handwriting. All right, number 2. We have a petri dish is filled with 250 bacteria cultures. The number of bacteria in the dish triples every hour. Represent the number of bacterial cultures in the dish for the first 5 hours as a numeric sequence. Well, let me draw a little picture over here. You don't have to draw this on yours. But let's say in the first hour we have this one little guy. Well, after 1 hour, this little guy triples. So now we have 3 little guys. Well, after another hour, these guys triple. So what do we have now? Well, instead of 3, 3 times 3 is going to be 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so that's a similar situation that's going on here, but obviously in the actual problem we have a lot higher of a number of bacteria. So represent the number of bacterial cultures for the first 5 hours. Now, I always think it's a good idea to start with a table with sequences, because it's a little easier to understand what the actual first term value is going to be. Because again, this is one where I think many students would make the mistake of putting this 250 in that first spot. Well, we started out with 250 bacteria, but after the first hour, it tripled. So what is that 250 times 3? That's going to be 750. Now, to get each value after this, it's just straight up multiplied by 3. Because the problem said that it was tripling, so 750 times 3, 2,250. Now, again, I just multiplied by 3 here. Now, keep going with this pattern. Now, I'm using a calculator here. Don't be scared of asking for a calculator. Alright, so these are all the values I got for the first 5 hours. Now, since it did say to represent this as a sequence and we gave a table, all we have to do is take these y values and list them out as a sequence. So a sequence is just a list. So it really is just this. Alright, so we're good with that one. Part B says, what is the number of bacterial cultures in the dish after 7 hours? And explain your reasoning. So this one, there's actually a number of ways we can do this. I actually think since we have the table made already, up to first 5 hours, and it asks for 7 hours, it would just be pretty smart of us to just keep going with this pattern. So to get the next value for that 6th term, all we have to do is take that previous value, that 60,750, multiply that one by 3. And again, feel free to use your calculator here. Now, to get that 7th value, again, I'm using my calculator here. We have 546,750. So it didn't just ask what is the number, right? It also said to explain your reasoning. So we can say this, that the number of bacterial cultures after 7 hours is 546,750. Now, explain your reasoning. How do we get that number? We know this because we multiplied our original amount, 250, by 3. How many times did we do that? Well, after the first hour was 750, and we had to go all the way down to the 7th hour. So we really multiplied 250 by 3 7 times.